All right. I guess we need to get started with this. I hope you had time to get coffee. I've had time to restart my computer, and lo and behold, it works better now. Pro tip, maybe restart your computer once in a while. So, this topic is about accessibility. Improving accessibility or achieving accessibility in your Vaadin application. Accessibility, or as the cool kids say, A11Y, is essentially about ensuring that people with any kinds of impairments are actually able to use your application or your website or whatever it may be. Sorry. Oh. Thank you. Didn't notice that. Is there an echo now? Okay. It seems really loud. Is it? Is it fine? Okay, it's fine. Anyway, so impairments. Okay, now that's better. Thank you. Okay, so that could be something, for example, like impaired vision. Could be full-on blindness, or just color blindness, or anything in between. It could be impaired dexterity, like fine motor skills problems, people with, I don't know, rheumatism, Parkinson's, or just, I don't know, missing fingers or whatever, anything that might prevent them from using normal input devices like mice, trackpads, or even keyboards. And of course, these impairments could be permanent or temporary. Like if you've broken both of your arms or something, you would have a bit of trouble using pretty much anything. So why should you care about these people? Well, for one thing, they are potential users, and you probably don't want to exclude any users from your app if you can avoid it. And of course, then there is the legal aspect. And I'm going to be focusing on the European Union today because we are in the European Union and I only have 45 minutes and I don't have time to go into other regions like the United States, but there are to a large extent similar laws there as well. So since 2018, all public sector applications and websites have been under an EU accessibility requirements directive. So that means that any public websites, any public applications that are provided by public institutions like the government or whatever, and for the use of the citizens, for the general public of an EU member state, must comply with accessibility regulations. I'm pretty sure you all know this. What I'm pretty sure not everybody knows, though, is that also the internal applications and websites used by public institutions, by the public sector in the EU, must fulfill the same accessibility requirements. So also the employees, the tools that employees in the public sector use need to comply with the same accessibility regulations as the ones that are provided for the general public. So this means that, of course, if you are building an application specifically for the use of a public sector institution, it falls within the scope of those accessibility regulations. But also, if you're just building some generic app, let's say, I don't know, documentation management or something, that a public sector institution may want to use and give you money for, they may be prevented from doing so if the app is not accessible. So they're trying to throw money at you, but they can't because of these regulations. So that's a pretty good reason to make quite a few many more applications and websites accessible than if it was only about those targeting the general public. So that is already in effect since many years ago. Then, in 7 months from now, the EU is expanding accessibility regulations to the private sector, such as passenger transportation, consumer banking, and e-commerce. So any consumer-facing application or website within these sectors also now has to comply with accessibility requirements. So quite a few apps do need to have this in good order. So how do we achieve it in a Vaadin application? Well, the first rule of thumb is to use accessible components. And since you're building UIs with Vaadin, you are probably using the Vaadin components, and that's good news. We have made significant improvements in the last few years in the accessibility of the Vaadin components. They're not perfect yet, but we have made improvements that have taken them from being actually kind of awful to actually really good. I would dare say that they're among the best in the available for any tech stack on the web today. And we are continuously making improvements. We are using an external accessibility expertise consultancy called Tetralogical, who assess the accessibility of all our components annually. So once every year, they go through our components and they provide us with a list of issues that they find. This is also how we know that we have made significant improvements. Okay, so then the next thing is about colors, color contrast and color blindness. Color contrast is, can affect a lot of people, for example, with bad eyesight, and color blindness is actually super prevalent. 8% of men globally have some form of color blindness, and I think it's like 1.2% of women. So it's a significant amount of people. I'm not going to go into a lot of detail about color blindness, except to say that there's one easy rule of thumb to follow to make sure that you're not making their lives difficult, which is to never rely only on color to convey information. So if you have a red-green indicator, for example, for on and off, also provide like a text alternative to say on and off, or an icon, or anything else in addition to that color. So that already kind of fixes that problem without having to extensively test your UI with color blindness simulators or something. Now, for contrast, that's about how well, for example, text is visible against whatever the background color happens to be. This is something that doesn't only affect people with bad eyesight. I'm sure you've all been in situations where you have had trouble reading a website, for example. I mean, I'm sure all of us had at some point used a cheap Windows laptop. Those TN screens can be absolutely horrible, even in the best lighting conditions. I was once in a project where we had to spend several days improving the contrast of the UI to really pump it up to the max, not because of disabilities, not because of bad eyesight amongst the users of the employees of the company, but because the company had invested in so awfully bad screens that they had trouble using the UI. Also, of course, it's 2024, remote workers might want to sit on a beach or something and work, and then there's the sun, and so, glare and so on. So a lot of situational impairments might be an issue for color contrast. So, okay, well, if you use the Vaadin components and the default Luma theme, things are in pretty good shape, at least if you're on V22 or later, where when we fixed some of the contrast issues that were in the default colors. There is one thing you might still want to look into if accessibility is important to you and you're using the default theme, which is that by default there is no border around the input fields, and that edge between the input field surface and, for example, a white background does not live up to accessibility requirements. But there's a simple trick since v24.1, which is a CSS property you can flip. It's called Vaadin input field border width. It defaults to 0, but if you put it to, for example, 1 pixel, you will get a 1 pixel border around all of the input fields, in all the input field, Vaadin input field components. If you do need to check your color contrast, for example, to check that whatever colors you use yourself are okay, I can recommend this tool, the Color Contrast Analyzer. For some reason, the URL says Color Contrast Checker, so I'm not sure what they want to call it. But anyway, it's an awesome tool. It's available for Windows and Mac. You have these eyedroppers. You pick the background or foreground color, and it will automatically tell you if that combination fulfills, for example, regular text, large text, or non-text, such as icons and services and so on. And then you can use this slider, for example, the lightness slider, to see how much darker or lighter something would need to be to fulfill the WCAG color contrast requirements. Next up, keyboard support. Also not something that is specifically disability, also not something that is specifically a disability thing, because a lot of people want to use a keyboard instead of a mouse for traversing the UI. For example, developers, or for example, data entry clerks, users that spend most of their time entering data into forms. They don't want to lift their hands from the keyboard to the mouse to do things. They want to do everything with keyboard if possible. And of course, any kind of power users who may want to be two people on the same keyboard at once to, I don't know, save the world from something. Anyway, power users, you know what they're like. So how do we ensure keyboard support? Well, the most important thing is to make sure that everything that needs to be interactive can be focused. Difficult to focus, to interact with something if you can't get keyboard focus on it. Also, make sure that the focus order makes sense. Like, try to make sure that the focus isn't jumping randomly around, but it actually follows in the logical order in which you would typically interact with those elements. Now, focus order comes directly from the order of the elements in the DOM tree, in the HTML structure. There is this set tab index API in Flow that you can use to provide a different tab index to override the default position of that element in the DOM order. I don't have time to go into the details, but I'll just say don't do that. Instead, try to restructure your UI if needed so that the DOM focus order makes sense. And of course, once somebody has focused an element, they also need to be able to trigger it. So if it has a click listener or something, make sure that it can also be triggered with space or enter. And obviously, any kind of hover-based interactions are tricky because you can't hover with a keyboard. You also can't hover with a touch screen, so that's another reason not to rely on hover. There is one detail I want to mention, though. Tooltips, the Vaadin tooltip component that shipped in 24.3, is actually not a problem in this sense because it also appears on focus, not just on hover. But otherwise, always, if you have a hover-based interaction, always provide an alternative to that can be triggered with just clicking or tapping or space and enter. So next up, small screen support. Obviously, mobile phones and tablets and so on have small screens. If somebody wants to use something on a mobile or phone, the UI needs to adapt to, you need to scale down to that size. And also, these days we have these split screen features in Windows and Mac OS. And a lot of people use those, power users, those, two people on one keyboard. Those people like to use this, and I'm sure many of you do too. And if you, of course, then have a really small pane on one side of the split, that's pretty much equivalent to a small tablet or a big phone. So what does this have to do with accessibility? Well, it has to do this. Browser zoom is used by people with bad eyesight to make everything bigger so that they can see it more clearly. And the rule of thumb is that you should support 400% browser zoom without requiring the user to scroll horizontally. That may seem like a lot, but if we take this part of the UI here and we transpose it on top of this is, by the way, an iPhone 13 mini. So it's on the smaller end of the phone size spectrum in these days. I mean, this would have been huge 10 years ago, but these days it's a small phone. So if we transpose that UI onto the 13 mini screen, it looks pretty much the way you would expect it to do on that, right? And in fact, if we render that same view on an iPhone 13 mini, it looks pretty much exactly like that. So how big is this? Well, the iPhone 13 mini is 360 pixels horizontally. And for accessibility requirements, according to the WCAG standard, you should support 320. So it's only marginally smaller than an iPhone 13 mini screen. What this means is that browser zoom support for accessibility compliance is essentially the same as mobile support. There are subtle differences, but they don't really matter so much, so I'm not going to go into them. So then, to provide small screen support, you do need to do some kind of responsive layouting. Vaadin has, for example, form layout, which collapses into a smaller number of columns as needed. We have app layout, which that collapses the navigation drawer into a hamburger menu. And we have menu bar, which can collapse the menu items into an overflow menu and so on. We are planning to provide more helper features of some kind for doing responsive layouts, but at the moment we don't really have much. Flexbox is, as you probably know, one of the CSS layout models. It's one of the easiest ways to create responsive layouts. Media queries is another one. It's a bit more complicated, but it also gives you a lot more freedom to do things. And then we have, of course, the CSS grid layout, which unfortunately is complicated, and we don't even have time to think about it today. But Flexbox. The great thing about Flexbox and Vaadin is that horizontal layout and vertical layout are actually Flexbox containers. They're just a nice API on top of Flexbox. This means that, so for example, horizontal layout is a Flexbox container with flex direction row. So this is just plain CSS. And there's a typo, it should say vertical layout. Vertical layout is a Flexbox with flex direction column. So what this means is that, well, by default, the horizontal layout doesn't do any wrapping. So when it overflows, it overflows. When the contents no longer fit, they just overflow. They can squish together to some extent until they reach their minimum size, but then they overflow, which is not what you want. You really want them to wrap, probably, or that's one of the things you might want. So luckily, wrapping is easy to do. You just apply one utility class from the Luma utilities enum, and then the horizontal layout wraps. Get style, set flex wrap, wrap. That's a lot of wrap, but you get the idea. Then we have media queries. Media queries are a way of saying, hey, beyond this breakpoint, so beyond this horizontal size of the viewport, apply this CSS instead. And as I just mentioned, horizontal and vertical layout are really just Flexbox containers with different properties for the flex direction, which means that you can just turn a horizontal layout into a vertical layout at a particular viewport size. So what this does is that when the viewport, the browser window width essentially, is 600 pixels or less, it transforms a horizontal layout called My Layout into a vertical layout. And it also applies another CSS property, align items stretch, which just makes the items that are now stacked vertically stretch to fill the width of the container. So it is CSS. You can't do it just with Java, but it is actually not that complicated. So if you've got all that covered, you're pretty awesome. I mean, you're helping this woman who needs to get new glasses, but hasn't gotten around to doing that yet. But you make sure that the contrast is sufficient for her to see. You're helping the people with color blindness because you're not relying on color to convey information. You're helping people with whatever motor skill issues who might have trouble using a mouse. You're helping them use your application. You're using people who broke their arm or have some kind of temporary impairment of whatever sort. You're helping people on those crappy cheap Windows laptops and the cheeky bastard on the beach. You're helping people who want to use your app on a mobile screen or in a split screen setup, and you're helping these guys save the world. So you're awesome. You're like person of the year. But we forgot someone. Who did we forget? We forgot the blind person, or the person who has some severe vision impairments, who even when you scale the UI up to 400%, they still can't see it or use it. So that brings us to screen readers. These are software utilities that people with blindness or severe vision impairments use to hear the UI spoken out loud because they can't see it. So there's a synthesized voice that reads everything out loud. This is called announcements. And the user navigates around the UI with a keyboard, not just by tabbing from one focusable element to the next one, because not everything is focusable. They also need to be able to see texts and so on, which is not focusable. So screen readers have something called a virtual cursor, which is a bit like a mouse pointer, except it's virtual. It's actually like a one-dimensional mouse pointer that can only move up and down, because 2 dimensions have no meaning if you can't see the UI. So to give some kind of idea of what the experience of using a web page through a screen reader is, it goes something like this. I'm going to be emulating a screen reader now because I originally planned on playing up a video clip of a screen reader reading things, but it's so disorienting that I'm going to simulate it instead. So, hamburger menu, app name, user profile, link, notifications, link, uploads, link, settings, link, user profile, heading, first name, text field, last name, text field, email address, text field, role, drop down, and so on. And even that is actually kind of not quite realistic, because you could still see that things were horizontally laid out. So in actuality, it's more like this. So things are just in a single one-dimensional list of elements. So it's a very different experience to use a web page with a screen reader than it is to use it with a screen. And although it would be great if every development team had someone who knew how to use a screen reader and assess whether or not the experience is adequate, it's a bit too much to ask that everybody would actually get used to using a screen reader. It's an overwhelming experience. It can be a depressing experience. It takes a lot of time to get used to. And it's not something I would necessarily recommend to most people. So what can we do to figure out, to get some understanding of how a screen reader sees and presents our app UI to the user? Well, luckily, there's something called the accessibility tree. So you probably all know that there is an HTML tree behind that basically renders your Vaadin app UI. So it's a simple tree structure with a one-dimensional tree. It's nested, but still a one-dimensional thing essentially. So the accessibility tree is a bit similar to that, except more abstract than an HTML tree. And the accessibility tree is what the browser provides to the screen reader to let it know what the content is. So the screen reader doesn't actually read the screen as you would expect based on the name. Instead, it reads the accessibility tree, which is a lot easier for it to do. So let's first have a look at how we access that thing, because it's available in Firefox and Chrome. Unfortunately, Safari doesn't expose its own accessibility tree. Don't know what's up with that, but let's focus on Chrome and Firefox. So in Chrome, you go to the DevTools, and next to the element, like the HTML tree, there's this panel with tabs. And you click the double arrow thing to bring up more tabs, and you click accessibility. And there's a checkbox that says enable full page accessibility tree. And then you get this little guy up in the upper right corner, and you click the guy, and that gets you to the accessibility tree. Firefox made this a bit easier by just, when you click accessibility from that list, it takes you to the accessibility tree. I also think that the accessibility tree in Firefox is easier to read. So let's have a look at it. On the left-hand side, the blue column, are the roles of each element. Roles are a bit like HTML tag names or element types, but more abstract. So you'll see a lot of generic, generic, generic. Generic just means that this element has no semantic meaning. It's not interactive, it's not semantic, it doesn't convey any information. It's just a container or a piece of text. Then we have text box, for example, which is any text input, and we have button, which is a button. And then in the middle column here, the pink text is the accessible name of each component or element. The generic ones don't need one because you don't interact with them. They don't really matter that much. But a text box should always have an accessible name. A button should always have an accessible name, because otherwise it's just an anonymous button or an anonymous text box. So what you can do is you can try to read through the accessibility tree, open all the nodes, read through it. Does the order of things make sense? This is similar to assessing the tab order of focusing elements with the keyboard. Does the order make sense? If it doesn't, the only thing you can do is restructure your UI, not necessarily visually, but in terms of how it's implemented, so that it does make sense. And are things nested or grouped within branches of the tree in ways that correspond to their semantic or logical groupings in the UI? So we have the role, and we have the accessible name. And then we have these properties on the side. Sometimes, for example, if you have a list, one of the items can be selected, and then that selection will appear in the properties panel there. But the name and the role are the two important things to check. Same thing for a button. So, okay, what if you have a button that doesn't have an accessible name? If there's just an empty string in that pink column? This could easily happen if you have an icon-only button. So we have a close button here, which just has the cross icon. And we haven't given it a label because we don't want it to have, say, close. We just want an X. So you can still provide an invisible label to this with the setAriaLabel API. And there's also a corresponding API in Hilla. So the ARIA label is an invisible label that only screen readers use. And so you can just give it the label close, or you can give it a longer label than what would fit into the button, because it doesn't really matter. Even better, you can give it a tooltip, which of course then also helps people who can see the screen because they might otherwise not know what that X means. Similarly, a text field might have an empty accessible name, even though visually it looks like it has the first name label here. But what is actually going on here is that it's not using the built-in label of the text field component. There can be many reasons for doing that. For example, when you want the label on the left instead of above, but you don't want to use a form layout to do that, so then you might end up using a span or whatever as the label. Now, even though these two elements are near each other in the accessibility tree, when focus lands on that text box, the screen reader will just say text box and not first name text box. So what you can do is you can associate that span with the text field to make it an actual label. You do that by first setting an ID on the span, like first name label, and then you set the area labeled by property of the text field to that same ID. So now there's a reference from the text field to the span. Next up, landmarks. You know how when you're in an unfamiliar city that you have something about it, like cathedral, you know where the cathedral is? It's in the center of the city. So in Turku, for example, the cathedral is a good landmark because if you want to get to the university campus, it's right next to the cathedral. So easy, good landmark. If you want to, well, the cathedral and the castle are in opposite ends of the city, and they're both by the river. So you can walk along the river either towards the cathedral or the castle, and you can find most of the interesting things in between. Most of the good restaurants and pubs and so on are along that route anyway. And then if you see this guy, turn back, you've gone too far, turn back immediately. So landmarks, super useful. And in a UI, there are similar landmarks. For example, there's typically a navigation area. There's a header area with like the name of the application maybe, and the user drop-down, things like that. And there's the main street where most of the things happen, the main usage area of the UI. This is typically the view, which changes depending on which route you're on. So as you can see, these are HTML elements because they're inside brackets, and those are actual normal HTML elements whose only purpose is to provide landmarks. So you can wrap your navigation into a nav, and you can wrap your header content into a header and your main view content into a main, and that will make these landmarks and make it much easier to find your way around the UI in a screen reader. Flow has corresponding component classes, nav, header, and main. And there's also section. If you want to split your section into further smaller areas, let's say you have like a list or like a grid, and then you have a form. Those are two separate areas that probably live inside of the main. You can split that main into smaller parts with sections. And then you can have a footer, for example, for the buttons and so on. So what these landmarks do is that screen readers provide a keyboard shortcut that brings up a list of all the landmarks on the page. And the screen reader user can just click one of those in the list and gets teleported directly into that landmark, into that element. So it's a bit like if we could just look at the cathedral and click it and get zapped to the cathedral. So it's even better than actual landmarks in a city. Other landmarks are headings. These H1, H2, H3, and so on, those elements. They're not just font styling elements. They have actual semantic meaning. They're headings. They're a bit like street signs saying, this is here. So you should use those, and you should also make sure that you're not picking the heading level, the 1, 2, 3, 4, 5, 6, just based on how big the font is by default. You should actually make sure that the heading level corresponds to the hierarchical level of that heading in your UI. So for example, here the H1 is the top level heading, and H2 is the title of the form, which is on a lower level hierarchically. And these headings also are available as shortcuts in a screen reader, so you can quickly jump into a heading. These landmarks and the headings are important because a complex app UI can have hundreds and hundreds and hundreds of HTML elements. So that means hundreds and hundreds of elements to traverse with the screen reader one at a time. So if you don't provide these landmarks, it will be very difficult, although possible, to use your UI. So, okay, you got that covered as well. Then you're super awesome. Like, we are truly the person of the year. This is already significantly better than 95% of all websites and application UIs out there. And it's not that difficult. And you're not just providing for those with disabilities, you're providing for the douchebag on the beach, and you're providing for the person who broke their arm, and so on. So you're awesome. Congratulations. One last thing. You might also want to test the accessibility of your UI. And there are many tools out there for doing this. We built, of course, one of them into Copilot, as we do. So you bring up the accessibility checker panel, you click check, and it gives you a list of things that might be wrong with your UI. And you can click one of those items, and it will give you more information about the ways that you are bad. It also does some really helpful things. Like, for example, at the top here, we have a button, and it says ARIA commands must have an accessible name. That's a kind of a weird way of saying that the button doesn't have a label. But anyway, if you click that one, it will also give you a bit more context. But then there's a text field and a couple of buttons, and you can actually provide that accessible name, that ARIA label, straight here in the panel. So it can not just find your problems, it can fix some of them as well. So that's a useful tool. But I also want to point out that any accessibility checker tool is only a tool. It will not give you a yes and no answer whether your app is accessible. It simply cannot possibly find all of the potential issues in your app. It's actually easy to build an app UI that is utterly inaccessible but still gives you a thumbs up on the checker. It will also give you almost certainly some false alarms, or at least things that are not really that problematic, but it's not very good at distinguishing between those things yet. But we intend to make it better. And this goes for any tool, any of these automatic checker tools. Even if it's not finding anything at all, it doesn't mean everything is hunky-dory. You still need to check things manually. But they're a help. So that's it. I have no idea how long this took, so I don't know if we have time for questions, but there's nobody at the door ringing a bell or anything, so maybe we do have some time. Matthias, do we have a microphone?
Incoming.
It's incoming.
This is a little bit weird because it's not only a question, but it's more like kind of an addition. Like,
Yeah.
How would you see, like, does accessibility also benefit regular users?
Well, yes. I mean, basically, the two people on the same keyboard, the guy on the beach, the person with the bad Windows laptop, and so on. So all of these things that you're doing, you're not just doing for people who are blind or something, which is, of course, a tiny fraction of your potential user market. You're actually helping so many other people in various situations that just happen to be also aided by the same things that people with disabilities are. So it's really a win-win for everybody. The only thing that is strictly disability specific is the screen reader support. All right, I guess we're done. Feel free to catch me later if you have other comments or questions. Thank you.